Wireless signals can travel through windows, walls, ceilings, and floors of your office building or of your home. Without using stringent security measures, a wireless network can be as open as a wired network jack on the outside of your building. So let's talk about some of the ways that we can secure our wireless local area networks. Two of the options that are from the early 802.11 wireless phase would be using SSID cloaking as well as MAC address filtering. Some wireless access points and wireless routers allow you to disable the SSID beacon frame, which means if a wireless client does happen to make its way close enough to your wireless signal, they still have to manually configure the SSID in order to connect to the network. Even though a wireless client receives a strong enough signal and may know the SSID of the wireless network, they can still be manually permitted or blocked from accessing the wireless network because of their MAC address. A wireless administrator can specifically permit or deny a wireless client from accessing the wireless network by using a list of approved or denied physical MAC addresses. Although SSID cloaking and MAC address filtering will stop most of those wireless clients that shouldn't be able to join your network, they won't stop all of them. Our crafty intruders can still easily discover the SSIDs of your access points, even if your access point is set to not broadcast it. And also MAC address filtering, crafty intruders can spoof their MAC address and still gain access to the wireless network. So the best way to actually secure a wireless network is to use authentication and encryption systems. We have two types of authentication that were introduced with the 802.11 standard. We have open system authentication and shared key. With open system authentication, this is perfect when you want to have free internet access in a cafe or a hotel or even a remote area. With open authentication, a wireless client can easily connect to the wireless network without having to use a password. With shared key authentication, we have a mechanism such as WEP, WPA, WPA2, and WPA3 to authenticate and also encrypt data between the wireless client and the access point. The concern here is that the password must be pre-shared between both parties to connect to the network. Within the shared keyed authentication methods category, we've got 4 different techniques available. We have WEP, Wired Equivalent Privacy. It sounds great, but this is one of the original 802.11 specifications, and this was designed to secure wireless data using a static key. What that means? It's not very secure, and WEP is no longer recommended and should never be used. The next one is WPA, which is Wi-Fi Protected Access. And Wi-Fi Protected Access was based off of the original WEP standard. It secures data using a stronger TKIP encryption algorithm, but still is not the best way to go. WPA2 is the current industry standard for securing our wireless networks. This uses AES encryption, Advanced Encryption Standard. It's currently considered the strongest encryption protocol. Last, we've got our WPA3, which is our latest and greatest security method. It disallows outdated legacy protocols and uses PMF frames, Protected Management Frames. Devices with WPA3, they're usually not readily available at this time in the market. Along with our authentication, we have encryption. And encryption is the method of us being able to protect our data. Even if an intruder has captured encrypted data, they still would not be able to decipher it in a reasonable amount of time. WPA and WPA2 standards use the following 2 encryption protocols. We have TKIP and we have AES. TKIP is used by WPA, and it provides support for legacy wireless local area network equipment. Now, TKIP addressed the original flaws of WEP, wired equivalency, but TKIP still is not as strong as AES. AES is the encryption method used by WPA2. It's the preferred method because it's a far stronger method of encryption. Now, when data is encrypted, people would have to literally capture that data and break through the encryption in order to get to the original data. So what should we use deploying a house wireless LAN? Well, first off, we're going to go with WPA2 authentication. We want the strongest authentication, which is WPA2 using AES encryption. However, we have 2 choices for WPA2 authentication. We have personal and we have enterprise. With personal, this is intended to authenticate devices using a pre-shared key. Our wireless clients, whether they be tablets or smartphones or Blu-ray players or TVs, will use the exact same wireless password as any other client in the house. There's no special server needed to deploy WPA2 personal. With WPA2 Enterprise, however, this is where you have a radius server, a remote authentication dial-in user service. This server is going to be a little more complicated to set up, but it does provide you a great amount of security. On this server, you will have multiple users configured, and these users will have a username and password combination. This radius server would be consulted by any wireless infrastructure device that a user tries to connect to. If a person on their laptop tries to connect to the wireless access point or router would consult the radius server to make sure those credentials were correct. WPA2 Enterprise was designed for enterprise business environment, but it still can be performed in a house. So how crazy can it get? Well, deploying a radius setup is not too crazy. It's just getting some of the basics down. When you do authentication in the enterprise and you have a radius server, we have to make sure that our wireless access point or wireless router can reach the radius server. And that means our wireless access point or wireless router has to know the IP address of the radius server. Also, because radius is running on the server itself, our wireless access point or router has to be able to target the port numbers that the service is reachable on that radius server. The common port numbers are 1812 for radius authentication and 1813 for radius accounting, but these can also operate using ports 1645 and 1646. On top of that, we want to make sure that we actually have a legitimate device asking if username and passwords are correct against the server. And to do that, we have the shared key. The wireless router or access point will have a shared key configured on it, which will be the same key configured on the radius server. As requests from our wireless router access point hit that server to ask about user and password accounts, we want to make sure that we actually have those legitimate sources of requests. So regardless of how you deploy a wireless local area network, you've got the basics of how you can keep it secure.
Why wouldn't you connect? Don't you know this is the server room?